Hello, this is Mr. P, and today we're going to learn about intervals. Intervals are basically just sets of numbers. They do have the property where any number that are between two numbers in the set is also in the set. But more generally, you can just think of them as like blocks of numbers or groups of numbers on the number line. And there are different notations for intervals. There's inequality notation, interval notation, and set builder notation. You're probably most familiar with the inequality notation. That would be something like 1 is less than x, which is less than or equal to 5, or x is greater than 3, as two of our examples. You could also think of this as x is between 1 and 5, including the 5, but not including the 1. The line underneath the inequality symbol means or equal to. And you can see on this interval you have x greater than 3. It does not include the 3, but any number larger than 3. Greater than on the number line means to the right of. Less than on the number line means to the left of. Now for interval notation, it's going to look like an ordered pair. In fact, it actually is two numbers separated by a comma. And let's take a look at what this would be equivalently in interval notation. Notice how your endpoints, otherwise known as the bounds, are going to be the same numbers. Those are the numbers for the intervals. The interval starts at 1, the interval ends at 5. So here we say this interval goes from 1 to 5. Now for the symbols on the ends, it depends on whether it's or equal to or not or equal to. If you do not include the endpoint, then you're going to use a parenthesis. If you do include the endpoint, you're going to use a bracket. So the parenthesis does not include the endpoint. That would also be called open at that point. And the other bound, which is 5, has the bracket, which includes the endpoint. So that would be considered closed. So this is a left open and a right closed interval. And also you can have what are called infinite intervals, and that would look like this one. This goes from, the interval starts at 3 because everything greater than 3. So in interval notation, we think of it as left to right on the number line is how we read it. The interval starts at 3, not including the bound, so it doesn't include the 3, but then it goes off to the right forever. It goes from 3 to infinity. You will never have a bracket on infinity because you can never actually reach infinity, so you can never actually include it, so it will always be open on the infinity side. And then finally there's something called set builder notation, where we're using set notation. So we're going to have braces, and let me just show you what this looks like here. The braces denote a set. These are parentheses, these are brackets, and then these are braces. So this is literally read as the set of all x such that vertical line stands for such that. And then you could say x is between 1 and 5, including the upper bound. You can say 1 is less than x, which is less than or equal to 5. Different ways you can say that, but the gist of it is this is the set of all x such that x is between 1 and 5, including the upper bound. It doesn't include the lower bound, but it does include the upper bound. Or if we looked at this interval, we could write it this way. The set of all x such that, that's going to be common in your set builder notation. So I was going to start out the set of all x such that, and then really the next part is just, could even be words, it's however you can express that group of numbers, and the inequality notation fits in nicely there. So this is the set of all x such that x is greater than 3. All right, let's look at a few more properties here. We talked about an open interval. The open interval is the one that does not include the endpoints. So this is read the open interval from a to b. That would be equivalent to the set of all x such that x is between a and b, not including the bounds, not including either endpoint. And have some examples there. When we go to graph these, let's look at what the graph of this would look like. We graph intervals on the number line, and remember we read these intervals from left to right just like we would on the number line. So This is where the interval starts, this is where the interval stops. We shade in the numbers in between, and then we use a parenthesis to show that it does not include the brackets. In earlier math classes and earlier algebra classes, you might have used an open circle and a closed circle. Well, in higher level mathematics, we don't use open and closed circles, we use the parenthesis or the bracket. So the parenthesis is what the open circle used to be, and we're going to see in a moment that the bracket is what the closed circle used to be. Matter of fact, let's actually go to the closed interval. For the closed interval, it looks basically the same, except it has the brackets. This is the closed interval from a to b is how this would be read. And it's equivalent to the set of all x such that x is between a and b, including the bounds, both the upper and lower bound. And when we graph that, on the number line, again, we go from a to b and shade in everything in between. So our interval includes all the numbers between a and b. And then on the ends, we're going to put brackets rather than a closed circle. And then that would represent all the numbers between a and b, including a and including b. And then the other type of interval that we talked about was the infinite interval. That's where your interval starts at a bound and goes off to infinity. And here we have, this would be the open interval from a to infinity, or in other words, the set of all x such that x is greater than a. We want to get comfortable with being able to read these symbols and know what each symbol means. And when we look at the graph of this, this would start at a, but not including a, because this is a parenthesis here, it's going to be a parenthesis here. So our interval begins at a and then goes off to the right forever. That's why we just have an arrow rather than a parenthesis or a bracket or something, because on the right side, it goes off to infinity. And it can go off to infinity on the left as well. Let's take a look at that. This infinite interval would be the set of all x such that x is less than b. That means the interval would start at b and go off to the left. But when we write that in interval notation, remember we write it left to right, so it's actually starting at negative infinity and ending at b. And in this case, they had it does include the upper bound, does include b. Notice again how the negative infinity, just like positive infinity, can never be included, so you can't have a bracket with infinity. It has to be a parenthesis. And then if we look at the graph, of course, you're going to have a bracket at b because it does include b. Whatever symbol is here is also going to be here. So it starts at b and then goes off to the left with the arrow. Alright, let's look at an example of what you'll need to be able to do in these sections. If I give you an interval, and I might give it to you in interval notation, I might give it to you in inequality, set builder. If I give it to you in one of those three, you should be able to rewrite it in the other two plus graph it. So let's take this example. This is the interval from 1 to 4. It does not include the 1, but it does include the 4. So if we write this as an inequality, then that would simply be x is between 1 and 4. And then notice how we have an or equal to with the 4, but no or equal to with the 1. That's because it does include the 4, but does not include the 1. So notice how the parenthesis equates to just the inequality sign, and the bracket equates to an inequality with an or equal to. And then set builder notation is pretty straightforward. Once you have the inequality, you can simply say it's the set of all x such that, and then you have your inequality statement. So the set of all x such that x is between 1 and 4, including the upper bound. And when we graph that, we can make a number line, and then our two critical points, these are our two important points, these two critical points, we're going to label those on the number line. You don't have to label every number on the number line. We're just going to label our critical points. And we want all numbers between those two, so we're going to shade inside and then you can look at this to see exactly what we're going to put. A parenthesis on the left and a bracket on the right, and that's going to look like that. So parenthesis on the left, bracket on the right, shade everything in between. You can see going from the interval notation to the graph is pretty easy. That's why typically you're going to be using interval notation most. All right, let's look at one other idea is intersections and unions. Intersections is to find the intersection, of course, we're going to take a portion of the number line that two graphs have in common. And for a union, we're going to take a portion of the number line that represents the collection of both of the graphs. So basically, unions and intersections are ways to combine intervals to make another interval. So, or to make a new graph. So these are going to be our two examples here. Now the sign for intersection looks like this. It's an upside down U basically. And that is equivalent to the logical word and. So for an intersection, it has to be in the first set or the first interval, and it has to be in the second interval. It has to be in both intervals to be considered in the intersection. And if you think of the idea of roads, let's say you have Main Street and First Street cross each other. They have an intersection there. Well, the pavement in the intersection, in the middle of the road in the intersection, that spot is considered to be on both roads. It is on Main Street and it is on First Avenue. So in order to be in the intersection, it must be included in both of the intervals. And the other symbol, the symbol for union, is the easier one to remember because that's a U. It's a big U. And the union is logically equivalent to the word or. So if it's on First Street or it's on Main Street, then that means any spot on the pavement on First Street or any spot on the pavement in Main Street, you'd basically add those two sets together. Add those two intervals together. All right, so let's look at the first one here. We have the open interval from 1 to 4 intersected with the closed interval from 2 to 8. That's how we would read that. So we want to think of only the parts that are going to be in both of these. So if we look at all our critical values here, we have 1, we have 2, we have 4, we have 8. If we put those on our number line, I just make a number line with 1, 2, 4, 8. And then I can think about each section individually if I wanted to. I would have everything to the left of 1 would not be included in either of the two. So I can ignore everything left of 1. Between 1 and 2, that would be in the first interval. All the numbers from 1 to 2 are in the first interval, but they're not in the second interval. So for an intersection, it must be in both of the intervals, so I would not shade anything from 1 to 2. When I go from 2 to 4, 2 to 4 is included in the first interval, 2 to 4 is included in the second interval, so that is something I would shade in. And then really quick, just looking at the last one, we have from 4 to 8. 4 to 8 is included in the second one, but not in the first one, so I would not shade that in. So the only spot here I would shade in would be from 2 to 4. And actually, it looks like they did that a little wrong. Oh, no, I'm sorry. Yeah, hold on a second. This would actually be, we're going to change this a little bit real quick. Bear with me just one moment. Okay, this should have, well, actually the easiest way to do that then, this actually should have been a bracket. So we're just going to write over it. Okay, this should have been a bracket because notice how 2 is included in this set, and also it is included in this set as well. So we should have included 2 here. I'll make a little adjustment. So it includes the 2. It does not include the 4 though, because the 4 is not included in this interval. 4 is in this interval, but it's not included in this interval. You do have to be careful about your endpoints. Okay, for the next one, we have, let's see, we have the open interval from 1 to 4 union with the closed interval from 2 to 8. Now for this one, they are taking all of the numbers. If it appears in either of the 2 intervals, then it appears in our union. So our critical numbers again are 1, 2, 4, and 8. So we're going to shade in everything between 1 and 4 is going to get shaded in. Everything from 2 to 8, so 1 to 4 was already shaded, so 2 to 4 is already shaded, so we're shading that all the way up to 8. So basically everything from 1 to 8 is going to get shaded. And as far as the endpoints, we have to see what happens here. Remember, if it appears in just one of them, then it's in the union. So starting with the 1, we have, notice 1 does not appear in this interval. It's not included in the interval because we have a parenthesis, and it's not in this interval. So we're going to have a parenthesis with the 1, and then with the 8 is included in this interval, and that's all we need. It just needs to be included in one of them. So we're going to have a bracket there. We have a bracket, and then, oh, they got that one wrong too. Okay, let's change that for them. That should also, this one should be a parenthesis, not a bracket. So we're going to make a little change to that one. So that's good. You can learn from your mistakes in mathematics as long as you do recognize them and learn from them. All right, so we want a parenthesis on the left side because it does not include the left endpoint. We want a bracket on the right side. All right, and in interval notation, this in interval notation would be, hey, at least I got that part right. So I got it does include the 2, does not include the 4. That would be the interval. And this interval would be open at the 1. Yep, and they did that right. Open at the 1, closed at the 8. It would be this interval. So again, remember, in order to be in the intersection, the point has to be in both intervals. In order to be in the union, it has to be in just one of them. And we're done.